So, dear students, in today's lecture, we are going to discuss about the chemical bonding. In this lecture, we will see how the metals make bonding between them. That is very important. So, let us start chemical bonding. Yes. So, before defining the chemical bonding, there are some basic terms. These are very essential to know us. What is element? The substance is having same kind of atoms in the molecule, that is known as element. What do you mean by compound? The substance which is having a fixed proportion of atoms of two or more elements is known as compound. And what is molecule? The substance is having the combination of two or more atoms of same kind or different kinds. The group of two or more atoms is called molecule. Uh, Please correct the spelling of molecule. MOLECULE, molecule. So consider one example here. We have considered H2O, in which H is the hydrogen, that is element. So as definition, the substance which is having same kind of atom in the molecule is known as element. So H, hydrogen, right? So this is an element. Then H2 also element as well as molecule, because as per the definition of molecule, the substance is having combination of two or more atoms of same kind, right? So H2, here there are two same type of element, so it is called compound as well as element as well as a molecule. Now H2O, it is compound as well as molecule, because H2O, it justifies both the definition of compound and molecule. So these were the basic terms. These will help to understanding the concept of bonding between the two metals. Right. So what is chemical bonding? There is some force of attraction between the elements, and this attractive force is known as chemical bond. And the attractive force between the atoms of a molecule is known as chemical bond. Yes, as per the definition, there is some force of attraction between the elements, uh, and this attractive force is known as chemical bond. The attractive force between the atoms of molecule is known as chemical bond. The attractive force that binds two atoms together is known as chemical bond. So these are the different definitions of the chemical bonding. The attractive force, the attractive force which holds various constituents like atoms, ions, etc. of two elements together in different chemical species is called chemical bond. So, dear students, in the screen you can see four different definitions, but meaning is same. So, this is known as chemical bonding. The attractive force which holds various some more definitions of chemical bonding are there. The attractive force which holds various constituents, atoms, ions, etc. Together and stabilizes them by the overall loss of energy is known as chemical bonding. The stronger and bonding, the stronger the bonding between the constituents, the more stable the resulting compound would be. Yes. Now, what is bond energy? The energy required to break the bond is known as bond energy, and uh, single bond is less than the double bond is less than the triple bond. So there are three types of bond: single bond, double bond, and triple bond. In which triple bond is the strongest bond as compared to double bond, and double bond is strongest as compared to the single bond. So weak bond is a single bond. Yes, this is the this slide is about the electronic configuration. Already you know and you have studied in the chemistry subject 11th and 12th. So this is the introduction, brief introduction about the electronic configuration. What is valence shell, what is valence electron, and what is valence. Because these terms I will use in the next slides. Valency, valency means whatever electrons participate to transfer or sharing to make the bond between two atoms of the elements is called valency. Whatever electrons will participate through the transfer phenomena or sharing phenomena to make the bond between the two elements or two atoms of the elements is called valence. Yes. So, what is the theory of chemical bonding? The atom can be viewed as a positively charged, that is known as the kernel, the nucleus plus the inner electrons, and the outer shell. The outer shell can accommodate a mixture of 8 electrons only. The outer shell can accommodate a maximum of 8 electrons only. The 8 electrons present in the outer shell occupy the corners of the cube which surrounded the kernel. The atoms having octet configuration, that is 8 electrons in the outermost shell, thus symbolize a stable configuration. Atoms can achieve this stable configuration by forming chemical bonds with other atoms. This chemical bond can be formed either by gaining or losing n electrons, NaCl, NgCl, 2, or in some cases due to the sharing of an electron like F2. So only the electrons present in the outer shell, also known as the valence electrons, take part in the formation of chemical bonds. Gilbert's-Lewis used specific notations, better known as Lewis symbols, to represent these valence electrons. Representation of electrons in the valence shell of the atom is known as Lewis dot symbol. So now, what are the types of chemical bonds? In the types of chemical bonds, there are three types of chemical bonds. Number one, ionic bonds, covalent bonds, and number two, metallic bonds. And these types of bonds in chemical bonding are formed from the loss, gain, or sharing of electrons between atoms and molecules. So first, chemical bond, that is ionic bond, we are going to discuss, and this ionic bond also called electrovalent bond. The bond is developed by transferring of electrons. Yes, this line is very important. Transferring of electrons. This bond is developed between the two metals, right? By transferring of electrons between the two atoms, is known as ionic bond, right? In the ionic bond, uh, one will be metal and other will be non-metal. Metal will be donor and non-metal will be receiver. Atom that donates his electron to another atom becomes cation, and positive charge is developed when atom donates his electron to other atom, and atom that receives electrons from other, and that becomes anion, and there is a negative charge. One important note is there: only electrons present in the outermost shell participate for making the bond between two atoms of elements. This is very important. The electrons, those are available in the outermost shell of the atom. Those electrons will take participate to make bond between the uh, atoms. And core electrons do not participate. Core electrons do not participate to make the bond. So in the ionic bond, now we are interested to see how this bond is developed. So in this, there is electrostatic attraction is developed between the atoms because of positive and negative charge, through which ionic bond is made. Yes, as we discussed in the previous slide, in the ionic bond is developed by transferring the valence electrons, those are available in the outermost shell, to the uh, to the nearest atom to make the complete bond. So when the electron is transferring to the other, uh, then the positive charge is developed, and the atom which is receiving the electron from other atom, on that atom a negative charge is developed. So because of positive and negative charge, there is a electrostatic attraction force comes into the picture. It is developed between the atoms. So we have metal A, non-metal B, and when the valence electron will goes to the non-metal B, then on the A positive charge is developed. And when the non-metal B receive electron from the metal A, it it gains it gains negative charge. So there is positive charge on metal and negative charge on non-metal. And because of this positive charge and negative charge, the electrostatic attraction is developed between these. So the example of this ionic bond is NaCl. NaCl. Na has 11 atoms whose electronic configuration is 281 plus. Cl. Cl has 17 atoms whose electronic configuration is 287. Now, in this case, these atoms are not stable, so we have to make them stable. Why they are not stable? Because in the Na, in the Na, that is sodium, in the outermost shell of the sodium, there is one free electron, right? And in the outermost shell of Cl, there is a seven electron. If this one electron uh, is transferred to Cl, this electron, this valence electron, that is one, it transfers to here, then it becomes to 8, 7 becomes to 8. Okay, then the in the cells of the sodium, there will be 2 electrons and 8 electrons. Now it becomes stable, and 288 Cl also becomes stable. So here, Na, this is the Lewis dot symbol representation. Na, sodium, there is one valence electron plus Cl. Cl has seven valence electrons. So how to represent, how to show the seven uh, electrons present in the outermost shell? So this is the latest dot symbol representation. First of all, fill the four electrons one by one, and right, one, two, three, four. Now then, start to pair and uh, put a next electron here, and they are making a pair, right? Pair, pair, and this is not making the pair. So if this electron moves here, then it becomes a pair. Okay. So in such a way that in the outermost shell of sodium, there will be no electron. So Na becomes stable. And in the outermost shell of Cl, there will be complete 8 electrons. So it becomes stable. So this bond is known as ionic bond. These are the some more examples for the ionic bond, electrovalent bond, right? This is sodium atom, fluorine atom, just we have discussed. So the same example is taken. Then the next bond is the chemical bond. Chemical bond, the bond which is made by sharing the electrons between the atoms of uh, non-metal elements, which is known as covalent bond. The bond which is made by sharing the electrons between the atoms of non-metal elements is known as covalent bond. Yes, non-metal means it means the atoms of both non-metal will make negative charge and will receive electrons. So in the ionic bond, we have developed a bond between the metal and non-metal, and in the covalent bond, we are going to make the bond between the non-metal, between the two non-metals. So non-metal means the atoms of both non-metal will make negative charge. Yes, will make a negative charge and will receive electrons. No any atom will give his electron to the another atom because in the covalent bond there is no metal, right? If there is no metal, it means no any electron will be transferred to the other atom, right? In such situation, so how the bond is developed? Because if the electron is not transferred to the other, it means there is a positive charge will not be developed, right? And if positive and negative charge will not be developed, then there will be no role of electrostatic force, right? So how to make the bond between uh, non-metal and non-metal? So in such situation, they share they share their electrons between them. Both needs is fulfilled. So in this case, on the one end there is non-metal, on the other end there is non-metal, right? And non-metal wants to receive electron from the other element, and on that side of the element is available, the electrons uh, of that element is also wants to receive electrons from the neighbor. So in this case, any atom, any element any atom cannot transfer each electron to the other atom. So in such situation, sharing phenomenon is possible. Electrons are shared between them and they make a bond. Such bond is known as covalent bond. In this case, there is no any positive charge and right. So that no any electrostatic force will be developed between the electrons. So the bond which is made by sharing the electrons between the atoms of non-metal elements is known as covalent. Whatever number of electrons required to fill the outer shell, the atom shares electrons. Non-metal means no donor, means no donor, no positive charge will produce on an electron. It means the atoms of both non-metal will make negative charge, right? Already we have discussed. And in this case, there is no any positive charge. It means that no any electrostatic force. I think this slide is repeated here. Okay, now see the how the covalent bond is developed. Yes, on the one hand there is non-metal, right? Negative charge, non-metal, negative charge, and both atoms want to receive electron, है ना, from each other. So this can be possible by sharing, right? That is known as covalent bond. In the covalent bond, there is two types of bonds: homoatomic bond and heteroatomic bond. In the homoatomic bond, same kinds of atoms are there: H2O2, Cl2, N2. But heteroatomic bond, different kinds of atoms: HCl, H2O, NH3, etc. So this is the example of covalent bond. Right? Examples of covalent bond. Here the example is taken H2O. Yes. This bond provides strong attractive forces between the atoms. That is uh, between the atoms. Example, diamond, which is the hardest material found in the nature. That is the example of covalent bond. Covalent bond. So now you can see the example for covalent bond. Right? We have considered here H2. Now in this this atom has one electron and this atom has one electron. Then how to make bond, right? So this electron will share with it and this electron will share it. So by this sharing phenomena, the bonding between these two atoms is possible. What are H2O? Yes, two elements of hydrogen and one is oxygen, right? So this is the sharing phenomena, and by the sharing phenomena, the bonding is possible between the atoms. So this is the strong bond. Now the last is metallic bond. This bond applies. This bond applies in most pure metals and alloys. Metallic bonding may be regarded as a special form of covalent bonding. The metallic bonds are formed between the atoms of metallic elements. Yes, in the iron bond, we have seen that bonding is developing between the metal and non-metal. And the covalent bond, we have seen that the bonding is being developed between the non-metals. But in the metallic bond, The bonding is going to develop between the metal to metal. So, in this category, there is a role of metals. For example, bronze, aluminum, copper, gold, silver, etc. In this, the valence electrons are not bound to any particular pairs of atoms, but move freely throughout the metal and form a negative electron cloud, which is shared by the positive ions. So this is the diagram for the metallic bonds. These are the metal ions, delocalized electrons. So through this way, the metallic bonding is developed. So thank you very much, and we meet soon in the next lecture. All the best. Thank you.